The IDTechEx Show here in Berlin. And who are you?
My name is Steve Reinhardt. I'm Vice President Business Development with UbiQD.
So, what is the UbiQD? What are you showing right here?
So our company is a manufacturer and developer of quantum dot materials. So they are inorganic semiconductor nanoparticles, around 5 to 10 nanometers. And what we're doing is we're downshifting high energy light sources to different wavelengths or different emissions, different colors, if you will, that can then be efficiently harvested by solar cells. That's what we're showing here in the window application.
So that's a window.
That's a solar window.
Cell. This is also a solar cell. Is different.
Why
do you say greenhouse?
So what we're doing in the greenhouse application is we're manipulating the spectrum of light that the crop will see to improve crop yield and plant growth. And so what you're seeing here is an effect called luminescent solar concentration. And as you can see, as the light shines on, we're converting that light to a different color. That light is getting wave guided to the edge of the glass, at which point we affix solar cells, and then we're generating power in the case of our fully transparent but tinted window.
So a tinted window
Yep.
disperses the light that comes from anywhere to the sides
That's correct.
and generates this amount of power right now.
Yes, and you can see as when I shine more light on it, as you would out in the sun, then you generate significantly more power. And so in the window application, we're converting it to visible light to near-infrared emission, which is very efficiently harvested by the solar cell.
So is this what the quantum dot? People are talking about quantum dot for TVs.
So that's
Is it also about wave guiding or directing light? Or
It's not about wave guiding light, it's about quality of color. So in TVs, you're using blue LEDs, and then you're lighting up green and red quantum dots to create a full quality color light.
So there's just some green ones and some red ones.
Correct.
That's it,
Yeah.
and it's just lighting them more or less
That's correct.
based on the colors.
And it's, so you have green and red quantum dots sitting in a film. The blue LED pumps those red and green quantum dots, and then you end up with a white with very pure colors.
But you are also changing some colors right here. Your quantum
That's
dots
correct.
are like yellow, or
So we can make any color between about 550 nanometers, which is green, all the way up to about 1300 nanometers in the near infrared. And so in the window application, as I mentioned, we're using something around 850 to 950 nanometers, which is very efficient for traditional silicon solar cells to harvest.
and why is it important to change the color?
Because it's more efficient for the solar cell is one. The second one is it imparts a more neutral color tint to the window. So if nobody wants to have orange windows in their house, other than maybe in Las Vegas, a casino or something. But what it does, it gives a nice neutral color tint that architects and building designers really want to have.
But how about this wave guiding, the spreading of the? It's not reflecting all the light to the corners, right? Just part of it, or
So what
most
we're
of
doing,
it goes through straight?
a lot of it goes through straight, that's correct. So in the window application, we're targeting to have about 50% visible light transmission. And so
50% of it
would go directly through. And then
It's not
50%,
used?
it's not used because you want to have light in the building.
Yeah.
And then 50% would be converted to this near-infrared emission.
Goes to the corners.
That's correct.
How do those side solar panels look like? They're like small areas, right?
So they're small area traditional silicon solar cells that are then just affixed to the edge of the glass.
How about some other competing transparent window solar technologies? How efficient are they compared to yours?
So I think ours are definitely on par. Our unique selling point is the ability to be tinted but fully transparent otherwise. So other competing things like organic photovoltaics, I think the reliability is not quite as good, and also you're going to have like a grid lines running through the windows or a grid pattern, which architects really don't want to have. So you can either the other approaches are like that, or like people just try and make traditional solar cells very, very thin, but they still have some optical distortion or defects in the window.
But you need to have squares this size, or you can have them much bigger.
We can have them much bigger. So this is just a prototype that we can bring to the show, but we're working now on panels that go up as big as a meter squared to do pilot projects, and then eventually we'll be doing things on 2 meter by 3 meter scale, commercial skyscraper window volumes.
So the quantum dots are like in a liquid form, or where are they?
So when we make them, it's a solution-based process. We typically dry them down to a powder, but what we do is we then dissolve them into a polymer resin, and basically polymer interlayer that's called in the window business is then laminated between 2 sheets of glass. So it's basically a laminated glass structure.
What's the price? It's going to be affordable?
It'll be very
Make a building with your technology?
Yeah, so we don't have a fixed price for the system yet, but we've done some modeling with the National Renewable Energy Lab in Golden, Colorado, in the U.S., and we're projecting now about a 3 to 5 year ROI for our product.
3 to 5 years, that's it.
Yes.
How does that compare with other systems?
It's hard to say because the photovoltaics vary so much, but I think we're very competitive for a window, and then we bring that unique point of being fully transparent and having zero
Does this whole waveguiding thing where the light goes on the sides, could it affect some kind of visual artifacts kind of things, or it's just going to be so smooth?
It's going to be pretty smooth. I mean, I think, I don't know, what do you think?
It's like a window.
Yeah, it's like a window.
And if you light it up...
yeah, you'll see we're generating more power. Yeah.
It's not doing any weird things.
Nope. Other than generating more power.
So how far are you from this being huge?
So right now we're still in the development stage. We have some government grants from NSF and others to work on this project, and I think we're aiming for a commercial kind of target production in 2 to 3 years.
And NSF is the National
Science Foundation in the U.S.
Okay, right.